I think we can start. Again, hello everybody. My name is Damir Medved. I'm Director of European Digital Innovation Hub ADRIA. And today we'll have a lecture about this, how the IoT technologies can be used to improve the business operation of small and medium enterprise that is basically specialized for solar infrastructure installation, and what was the driving for them to contact EDIH ADRIA, and also how we help them during this process. So maybe just a few words about the EDIH ADRIA. So we are a European Digital Innovation Hub. We are located in Rijeka, Croatia. I'm working on the University of Rijeka, that is a project coordinator, and we have 6 partners altogether. 2 industrial companies. One is Ericsson Nikola Tesla, another one is Infobip. These are 2 largest Croatian IT companies. Then we have the University of Rijeka and University of Pula, which with around 80 different scientists in the area of the artificial intelligence, networking technologies, and so forth. So this is a basically pool from which we are taking the knowledge to assist our users. And also we have a kind of business supporting organizations like a Smart Tree and these Step Tree. These are 2 organizations which are specialized in business development, connecting with the business infrastructure and so forth. So with this mix of the organizations, so universities, industry, and these business organizations, we can provide quite comprehensive services. So today we'll talk a little bit about the kind of general overview. Where is the solar sector currently? What is our current situation? Where we are here? What is the business needs? And what actually generated this 3-tech cable, which is a SME, which we helped in this process to go into the domain of developing a new project and new ideas. Regarding the current situation in the solar market, I think that's quite obvious. There is a huge, I would say, huge demand, and there is a lot of the successes in the installations worldwide. But you can also see that this market will be, we can see the significant increase in next years. There are many drivers for that. Obviously, energy transition is a big one, but also lately there are also some other aspects like improving the resilience of the local communities, giving opportunity, for example, to citizens to participate in the energy market transition. And basically the solar energy is providing these capabilities. Obviously it's quite easy to install, and it's very, very scalable for very small installations on the roof of the citizens to the large solar power plants which are installed in industrial domain. So again, what we can see in the next period, the most of the solar energy market will be in this photovoltaic domain. There are these thermal, solar, and concentrated energies. But I would say for this our story and for the area where the 3-tech cable is working, this photovoltaic domain is most important. As you can see, the market is growing really significantly. There is a lot of capacities built in, especially in China, which is producing most of this photovoltaic infrastructure that is now implemented. But there are now the number of initiatives that, for example, in Europe, we should strengthen this local market as from the producing of solar power cells to the inverters and any other components within this market. This is important to understand that in the next period, maybe we should not see this kind of constant decrease of the prices or the cost for the photovoltaic. If the production will be transferred to the Europe or other developed, more developed countries, then probably we cannot see this kind of decrease of the pricing. But anyway, the current installations and the current pricing is already the PV plants or PV infrastructure is I would say it's the most affordable. Actually, the new if you are building new energy infrastructure or new production capabilities, if you are doing this with the PV, then it's the cheapest one. Here on this slide, you can also see the huge increase in the last 2 years of the implementation of the installations. Obviously, the leader in this is China. They are really almost 60% of all new global installed new power plants are in there. And that rate will also increase because they have really major plants in this area, and they are really have these local capabilities to do it. Also, if you look to the other renewable sources, energy sources which were installed in 2023, you can see that the huge amount is really 77% is coming from the PV. And that's very important to understand. And also it's important to know that, for example, in Europe, most of this installation is distributed. So there is a huge number of installation in the private sector, basically on the citizens, which is bringing a lot of the benefits, but also bringing a lot of the challenges from the energy infrastructures. One of the benefits of this quite significant increase in last year is also, I would say, great contribution to reduction of the CO2 emissions. It's not so significant if you see what are the other emissions coming from the fossil fuels, but anyway, it's a sign that we are really moving forward in a quite good direction. Now, the solar power applications, they have a number of benefits, a number of applications. So it's not just the generation of a solar power of the electricity. There are many other things which should not be neglected. So if we are talking about for example, the heating system, for example, water heating or let's say thermal heating, some applications in agriculture and so forth. It's not just that we have a PV plant, so there are many other technologies which are available there. And it's obviously a good idea to have kind of holistic approach so that we are analyzing each particular case, and you will see later what that means in the platforms. And then we are providing kind of holistic solution, which is bringing us the maximum energy conversion efficiency. There are a number of the benefits of solar power. I think here I listed some of them, but I would say one probably most important will be that is giving the opportunity to much wider group of entrepreneurs, of citizens to participate in the market. So if you talk about some let's say wind generation or hydropower, usually it's reserved for big implementations, for big infrastructure, but solar is really making all this process democratic. And then it's also this decentralization of the sources is increasing the reliability and then the resilience of the networks. So I would say in general there are really a number of the benefits, and that's one of the reasons why we can see this quite fast expansion. Now coming to the problem that will be that the treaty cable is trying to resolve, it's also important to understand how the solar power energy and especially the smaller power generators can support these let's say balancing of the energy network. So you know that the energy, we are now currently living in a world where we have one paradigm, and this is that whenever we activate demand, then we automatically supply is created. So that's kind of a traditional hierarchical view where you have a big production, you have a, let's say, nuclear power plant or a hydropower plant, and then you have a transmission systems, you have transformers, and then on the end you have these small consumers. And the system was built quite hierarchically, and most of the current implementation worldwide are still like that. But then you have the problem of this different type if you are introducing the production into the edge, like in this in a scenario when you have a local power PV plant on the roof of your house. Then you have kind of additional uncertainties which are present. It's not uncertainty of how the energy is consumed, but there's also uncertainty of energy production. And then there are a number of different scenarios how that can be mitigated by introduction of the energy storage and so forth. But what is interesting that there can be also quite a lot of the positive effects of this distributed energy production, but to avoid any kind of the problems, kind of new technologies is needed, and kind of new types of integration of these solar power plants is needed. And now there is we are coming to the area which is quite important. So we can have these solar power plants. We can have people that have this on their roofs. But then also it's very important if we can create kind of the energy communities. So why the energy communities is important in this sense? They are important because they are enabling, they are giving you kind of the quite efficient way to, first of all, the balance energy consumption within the energy community, so in kind of the local area. But then it's giving you also opportunity that any excess of the energy that is present within the energy community, it's more efficiently then distributed to the network or actually sold on the network. So this is very important. If you see this hierarchy, we have what is establishing today the energy communities, and there are a number of them. There are kind of two different types of the energy community. It's a renewable energy community and a citizen energy community. The first one is kind of territorially limited, and but does not have a limitation in the sense what kind of energy or what kind of source of the energy you have. The other one, citizen energy communities, is not, in most of the cases, not is not located. There is no locational restriction. There is no territorial restriction, but usually is restricted just on the generation of the energy, electrical energy. So if you have the energy community, then you have these capabilities that you inside this energy community. First of all, you can sharing energy community within the energy community, so within the energy community member. However, which is the thing which is a little bit more important or more interesting is then you can see kind of additional advanced operations where you can maybe with this energy community capabilities you can produce the production load balance. You can participate in energy balancing. Maybe you can offer some additional services like EV charging and stuff like that. And then if you are moving up, then you can really, if the energy community is big enough and has appropriate infrastructure, then it can really make quite significant role in stabilizing the local energy situation. It can participate, can provide the flexibility to the market, it can facilitate the local energy market and so forth. And kind of in the last instance, if this energy community is a really big one, like the energy community that are existent in Germany or in Belgium or in Netherlands, they can really have really huge role in this balancing demand and supply and so forth. But I would say in most cases we are currently in a stage, this basic operation or this advanced operation. And one of the key elements why the treaty cable decided that they need kind of more advanced platform is what is shown here. So if you want to share, or if you want to, let's say, create energy community, if you want to share energy between the members, then you need kind of infrastructure that is supporting there. Here is a picture that you just depicting this one. So if you have some kind of local installation, you need some kind of a local sensors. You can need some intelligence in devices. In this case, this intelligence device is basically inverter. which is a component that is converting the DC energy from a solar cells to the energy that is usable for end users. And then obviously all of that have to participate, first of all, in this energy committee, but then also is participating in this, let's say, entire energy ecosystem. Anyway, to be operational, it's very important so that can work only if all these components which are present in all these elements can communicate together. They are compliant with different protocols. They must have certain capabilities, and then you can really make all these kind of benefits that I was mentioning earlier. So coming from this theoretical background, we are coming now to the practical example. So all of that was kind of initial driver for Treaty Cable to establish the infrastructure that will enable them and their customers to participate in this kind of organizations, let's say. So what were Treaty Cable customer needs? First of all, the Treaty Cable, it's a small and medium enterprise. It's located in Rijeka in Croatia. They are a renewable solution energy provider. They are quite large. They have over 100 installed, more than 100 installed different size of PV plants, from the industry grade to the local communities. They are quite active providing this infrastructure also to the municipalities. So I would say that they have quite a lot of the understanding on how technology is working, what are the obstacles. They also spend a lot of the effort in training of all these customers regarding what are the benefits of introduction of the PV infrastructure in their energy, let's say, consumption chain and so forth. So they are basically providing their full cycle. They are providing from the projects, from the assessment, from the initial calculation. They are dealing with the projects, kind of supporting the legal, the paperwork, but then also practically installing the infrastructure and then eventually monitoring that. Now, when they approached us, we identified, so that was part of the European Digital Innovation Hub procedure. First of all, we did a digital maturity assessment, where we identified that they have quite good understanding of the digital transformation. So they understand what kind of steps they have to perform and what kind of technologies they have to acquire, but they didn't have appropriate knowledge to define what kind of digital transformation strategy of their platforms is needed, and what kind of let's say technologies or protocols should be used. So in that sense, we provided them with the support. We created a kind of task force, which then helped them during this digitalization process. So how this? So what basically they did? So they are installing power plants, but they did not have appropriate monitoring system. They have individual monitoring system. What they'd like to have is integrate all that together into one unified platform, because they are not single platform vendor. They are basically, depending on the type of the customer and the size of the customer and the customer demand, they are offering multiple types of the vendors. They are offer multiple types of technologies, and they see that that's kind of the problem for them. They now have more than 100 plus installations, but maybe from 5 different vendors. So they would like to establish kind of remote monitoring, failure prediction, all these kind of things, which will enable them to have a shortest possible response time to any kind of problems that can be present there, but also to establish the foundation for all of these, all those customers to participate in energy communities. So they were trying to enable them. If they have a solar power plant, they should be also able to participate in energy communities, and that was the core idea. They have some kind of internal existing data collection capabilities. And in their particular case, they have some of the data was captured directly from the solar power plant. So they first established, they already have some kind of data capture capability. So they were collecting data both from the inverters of this system, or they have certain, in certain situations, they also have APIs if there is some kind of open data available from the vendors of this infrastructure. So they were collecting, in some sense, already collecting some data, but they would like to improve this process. Their idea was that this kind of data processing capabilities, which they would like to have, should be based on the open standards, on kind of the open platforms. And in that sense, one of their propositions or proposals was to use platforms like Influx or that should be deployed on DigitalOcean or something similar. That was kind of starting point. So idea was that within this test before the best exercise, we should test these different types of platforms that are available. And the last thing that will be quite important, they would like to introduce these different types of the monitoring. So they would like to have kind of dashboards which can actively or proactively monitor situation in the solar power plants they are controlling, but also they can send alerts to their customers, and also idea was to have kind of reporting capabilities present. So that was the customer need, and the solution where we started to, first of all, we identified who are the partners from this portfolio what we have inside the company, inside the EDIH project, and there was we decided it will be Ericsson Nikola Tesla. It's a company that has quite a lot of experience with this kind of integrating different types of IoT-based infrastructure. And also the University of Rijeka actually participated in this. And the idea was that we should demonstrate to them two different approaches. One will be completely open source, flexible. It's based on the Node-RED platform and Influx database. So both of these platforms are open source. They are available. They are very affordable, but they have some their own challenges. And the second one, we presented the Ericsson Insole platform. That's a platform that was built by Ericsson, and it's demonstrating what are the capabilities of kind of industrial approach to that. So idea was that the treated cable can make assessment of both of the platforms, and then on the end they can make their own decision what kind of solution is best for them. So the test started by collecting the data, the connected data from this infrastructure that they already had. There was certain number of solar power plants used for this trial, and then there was two different. The data was entered in these two different types of the platform, and then the capabilities of each of the solutions was compared and basically provided to them. So they made kind of the testings. So the Insole platform provided a more comprehensive solution. It's an industrial level of the platform, but has some additional costs which are coming with this platform. On the other side, the Node-RED has this benefit that it's open source. There is a lot of training materials available on the internet, so it's quite easy to make any kind of integrations and customization, but basically demands somebody with a little bit more knowledge on the treated cable. So what was the impact that was demonstrated, and what will be impact for them? Basically, all the pictures you see in these presentations are coming from the 3T cable premises, and then the recapture during this the pilot phase. So the demonstration, both of the platforms demonstrated it's easy to establish this real-time monitoring, which is it's quite easy to establish the alarms, different thresholds. However, the capabilities of Ericsson platform are much greater. So they have a lot of these AI capabilities built inside. They have this kind of rules engine built inside, which is enabling you to make different types of internal automations and so forth. On the other side, the monitoring established by Node-RED was also quite efficient. And I would say the key dilemma here was, on the end, it's coming the cost. So basically, the cost will define for them what solution will be used. Also, both platforms demonstrated that the maintenance of these plants, if they are connected to such a platform, it's much more easier. You can have easier tracking of the faults on the plants. You can have kind of much more direct information. You can direct information also propagate whatever is needed through the, for example, WhatsApp interfaces or Viber. In that sense, the maintenance of the plants is much faster and much easier. And also, as the platforms are now capable, both platforms and the data was stored in this influx database, the much more data was captured, which means that 3T cable now can make a little bit more advanced analysis on these data sets that were captured. So that was quite interesting for them, and also they can make any kind of adjustments, or they can have additional searches or additional analysis of a data once if the data is in your or actually in this sense in their platform. There was a number of the lessons learned. For example, they identified that some of the platforms they were previously using or offering, let's say, did not have appropriate interfaces available. And that is making, for example, transferring the data from that infrastructure much more difficult. So they made the decision, and it's not just for the 3T cable, but that will be also difficult for owners of that infrastructure if, for example, they would like to join the energy community. So that's important, and then they immediately informed their customers, and then for every new customer, now when they make any kind of offers, if they make a training, they are emphasizing this need of the advanced interfaces and how that should be present in, for example, if you're buying inverter, that inverter should have certain API or certain communication capabilities. If this is not present, it will be almost impossible or very difficult to integrate that in energy community or have any kind of more advanced. And it means on the longer term, that can really bring lots of the benefit for the end user. So maybe this inverter is a little bit more expensive on the installation, but at the longer term, it will bring a little bit more benefits. The second thing, what was quite important for them, is that they really identified a lot of these operational costs can be minimized. If they have very good quality remote monitoring, immediately they can see some of the problems. For example, if you have a lot of the fluctuation of the voltage, for example, in some local premise, then usually the inverter is coming into shutdown, and then you have a loss of a production. So if you have a very efficient remote monitoring, you can see that this is happening, and then you can communicate with your local DSO and basically local energy distributor and try to see where is the problem. They identified that in many cases that kind of information was not present. So the users did not have information that, for example, there were shutdowns of the inverter because of the voltage issues and so forth. And that's also, it's not just bringing up the efficiency of energy production, but it's also, I would say, it's hugely increasing the customer satisfaction. So with this advanced monitoring, the customers are sure that somebody is really taking care about how it's working. Now for the 3 cable, is very, very important that with this kind of advanced monitoring and these advanced capabilities, they are really, I would say, leader, especially when we are talking about how all these customers of 3D cable will be participating in energy communities. And then in the longer term, then also can participate in aggregation services and maybe in the future in kind of the balancing services. So if this first step, it's a very, very important first step. If this step is completely, I would say, is completed properly, if the whole infrastructure has appropriate interfaces, then basically all these next steps can be done without any problem, bringing a lot of the benefit for the end users. I would say obviously if the platform PV platform is monitored and if it's working efficiently, then obviously can reduce the carbon footprint. So basically, what are their expected outcomes when everything will be completely and fully operational, and when will be the number of the where theoretically where all the customers will be connected and so forth. These are some calculation expectations. They believe that these downtimes can be really reduced because they will have a lot of information in advance. If we talk with the local DSO, maybe some of these things can be prevented. So in longer term, for sure, there can be some reduction in downtime. Connected with that, probably if this downtime is reduced, and if there are some other information available, for example, if they can remotely monitor the how dirty are solar power panels, and then if they can inform the customer that they should be clean and stuff like that, which is coming from the measurement system, then in that sense also the energy efficiency can be, I would say, achieved. It will be, we can produce a little bit more energy. The maintenance costs, they're also identified. In many cases, they can resolve some of the problems remotely, or they can prevent some of the problems remotely. In that sense, that was a reduction of the maintenance costs, so the people were not, the service team didn't have a need to go to the remote areas. I must say that the 3T cable is working. The most of these installations are in urban area, but they have significant amount of installation in rural area, in the mountain area, or some inside, and that's basically a problem. The last thing I have here is that the customer retention is also, I would say, was increasing. All the customers, when they propose to be part of this advanced monitoring system, then we had they accepted that, and they see that this basically a small fee which they have to pay for these remote services is very well it can be very well beneficial for them. What is also important, all this knowledge was, so 3T cable also created a number of additional, so they changed their materials, promotional materials, educational materials, and then also they introduced this need for more advanced capabilities of inverters and this monitoring platform, and that is, as I said, already showing benefit for them. So they made a kind, I would say, important, because they are preventing their end users maybe to purchase something or equipment that will prevent them in the future to participate in energy sharing. So that's, I would say, quite important element. Also, basically, as the company is now with these efficiencies, improved efficiencies, what they have now, they have these capabilities basically also to do more work with the same number of the people. Actually, when they are now working on establishing kind of the solar power plant monitoring center, when it will be center which will have a team which will remotely then monitor. Current plan is up to 500 solar power plants. Currently they have 130, but they would like to come to the 500. And then with this central system, all operations can be much more efficient, and that's one of the things they would like also to expand their businesses. Okay, last few slides are talking with the lessons learned. First of all, it was extremely important that management of the 3T cable decided that they should go in this pilot. They should seek for the services. they should really clarify all technical problems or all technical aspects of this future solution before they come or before they go in a financial, before they go in a real investment. So this is one of the key aspects of EDIH ADRIA is really that this test before invest is actually in literal form. It's really test something before you are going to investment. So that was for them very important. Now they have a very clear picture where they have to invest. Also, they basically decided to create to choose a solution which are user friendly. In a sense that everything which will be provided on this platform should be also user-friendly, so their users can easily access this information, or can be also kind of motivational for them. Maybe some kind of gaming can be introduced in the future, some kind of competition. That's something that is interesting for the energy communities. They also basically involved different people. So when we were working on this pilot with TT Cable, there are different persons present there. So there are technical staff present, but also people from the sales department, the marketing, and so forth. So all of them contributed to the requirements, what they actually need, or from these kind of the platforms. And now the last thing, which is actually, I would say, quite important. Now they understand the importance of hardware, I would say, compatibility and capabilities of this equipment. So here it is just a slide of this interfaces, documentation, availability. So if you would like that this equipment is participating in any kind of more advanced scenarios, then this equipment should have at least some of the interfaces which are present here. Unfortunately, they identified that some of the interfaces or some of the equipment they sold in the past did not have this kind of interfaces. It was a cheaper equipment which does not have these kind of interfaces. Maybe this that was closed solution and so forth. So one of the business decisions they made, it's quite important, that they will not offer anymore some of the equipment they were offering up to that moment, because if they would like to establish what I was explaining, the all equipment must have this appropriate interface. So that's for them was very important business decision, and that is telling them that they are really going into the kind of trying to have a much more capable or use much more capable technology. So what are done? So basically, they saw that for many of these things, they need a lot of additional training. They now understand the complexity of this energy balancing market. So they started as a company that was just installing solar power plants, but they are now moving into the area that will be the company that also monitoring solar power plants, supporting the energy communities, and then moving to the ladder, to this competence ladder. And for that, they need a little bit, I would say not a little bit, but a lot of additional knowledge. And in that sense, also they will employ the people that have these kind of competencies. And also they see the value of this digital transformation support or this testing what we provided to them, and they are decided that they will also continue working with us in some next project, because they realize that probably due to the complexity of this energy market and energy technologies, they will need to be part of a larger group that can provide these kind of services. I think this is the last slide. Basically, key takeaways. Initially, they started with idea to use these new technologies to remote monitoring solar power plants, which will then bring a lot of this additional benefit for the end users. But on the end, they realized that it was not just that, but also they learned a little bit about how to move forward with their internal knowledge about how all of that can participate in energy communities and future energy market, and therefore, but they understand that what is done in this phase is foundations for all that. So I would say the final result for them was very successful, and they are really more moving forward. So this was one of the first projects we we concluded first TBAs. Now they are basically making some already investments, but now we are waiting to some funding that will be available, research funding, but also operational funding that will be available from the Croatian government in the beginning of next year. And they plan during 2025 to use this funding to build the final version or operational version of a system what I was presenting today. With this, I will conclude, and I would like now to open the floor for the questions. So, if there are any questions, I'm really happy to answer to them. So, all of the materials, this recording of this session, but some of the materials that are present in this presentation, they'll be available on the website, and then you can maybe go through again and see what are the particular technologies that were used. Good. Any questions? Just a second.
Damir, there is a question in the chat.
Just a second.
Yep.
Okay. Simon is asking what were the main success factors from the perspective of EDIH ADRIA. So I would say the main success factor for them was that they now fully understand the energy market. So they learned a lot about the energy market. So in that sense, they're adopting a business strategy they currently have, in a sense that they will a little bit more train their existing people, which are already have there. They will hire additional people with specific knowledges. They will adapt a little bit the marketing strategy to be able to use these new capabilities, which will these new platforms bring to them. And in that sense, also to change the education. So they are spending quite a lot of their effort in educating, especially the municipalities. So I would say that the success is the main success factor is their ability, they're changing their ability to learn about new technologies, and then in a short period of time apply this knowledge to broaden the market potential they have, to broaden their portfolio, and then maybe to avoid some future problems by avoiding certain vendors which did not have appropriate capabilities built inside their equipment. And so what did customer most value? They value most, I would say, from our approach. So as we have a partner, two partners basically, one was Ericsson, Nikola Tesla, another one was University of Rijeka. So they for Ericsson demonstrated them, for example, what is the industrial approach to their problem? You know, what kind of IoT technologies can be used? What kind of protocols can be used? What kind of thing? What about the reliability of the exchanging of information? You know, what kind of things they have to think about it? They'll explain to them different types of the protocols, different types of the benefits of or strengths or the weaknesses of each of the protocols present. And then also talking about also infrastructure, they learned about for example, the quantity of the data you should store, what kind of data you should collect, what is needed there, and so forth. So I would say that the most valuable thing was this ability that during this test before invest, they learned a lot about the infrastructure. They enhance their knowledge about the capabilities of technologies they already have, they already sold, and basically to understand how they can improve their current business processes. So understanding of the technology, understanding of the business process, how to improve them, and ultimately how they can improve their product and services portfolio. That's basically the best thing they got from this project. Duration of that was around 6 months. So from the beginning, when we started working with them to the end of the project, there was around 6 months in this customer journey, what we have with them, from the specifications, understanding of technology, what they need, they'll make some tests, evaluation, and so forth. So as said, basically, I would say that the time scale is here a little bit skewed, in a sense that they are waiting for the financing that will be available from our. There is a kind of funding in the beginning of next year where they can apply. If they will get that funding, it will be some kind of co-financing, I don't know, 50% or something like that. Then this return of investment can be obviously quite shorter. They make some calculations that the entire investment, now obviously depending on the, but kind of initial platform, the investment can be returned basically in a few months. If they would like to have more advanced capabilities present there, like some AI capabilities, stuff like that, then obviously the implementation will be much more, a little bit more expensive, and then this return investment will be longer. I would say here it will be from some calculations from the basic monitoring system in less than 3 months return of investment. If you need much more advanced, if you have much more advanced capabilities, then probably longer. Obviously, everything depends on the number of the solar power plants you are connecting, because there is some kind of fixed cost of the system. It's a platform that has a fixed cost implementation, and then there is some cost that is related to the data and to some interfaces. So their target is, if they can, to connect as much customers as possible, few hundreds, ideally all of their customers they currently have. So they would like to connect all their customers base, but if this is feasible for everybody, it will be seen. So I would say it's very, very financially, I would say return investment is very, very efficient. Okay, Simon, any other questions? Well, if not, I would like to ask you to...
Damir, excuse me, there's another question being written in the chat by Maria.
Okay, sorry. Yeah, okay.
Oh, no, it's just a comment.
Okay, yeah, more than welcome. So anyway, we are really open. This is basically, this presentation is recorded and it will be available, but EDIH ADRIA, we have our websites, and there is I would say the contacts are there, so if you need any kind of information, you can find it there. Also, we are preparing on our website a catalog where some of these success stories will be presented with even a little bit more detail. And also, we are more than happy to connect you with our end users. If you like to have some direct information from them, you can freely contact them, and you can talk also with them. I think it's important. I see also there is a question regarding are you getting the results expected? Marta asked it. So if yes, if so I don't know if you're asking for EDIH or for the customer. So yes, the answer of the customer, yes, they are really getting the results they are expected, even above that. I would say way above that initially. So I said they initially started in this test before invest with some idea, but as they learned, their ideas a little bit changed. So I would say it's much more than expected. And from the EDIH ADRIA point of view, we are really more than happy, or we are really happy to have this kind of customers. Up to this moment, we finished around 20 tests before invest, and I would say that in all of them we provided quite significant impact to our users, and almost all of them are now going into the operational phase. Unfortunately, in our case, in our situation, a lot of them are waiting from this additional funding that will be available in the beginning of next year, but then they can move really forward. No, we are not. So we are basically the EDIH ADRIA project is European Digital Innovation Hub. We are EU financed and from the Croatian government, and all the services we are providing are free of charge. We are not invoicing these services as EDIH. However, all these services provided, they are noted basically, and they are provided as they are kind of defined as a service provided by EU, and in that sense they are not paying anything. It's free of charge for our end customers. Let's make this in a simple way. Okay. If there are no further questions, I would like to ask you to fill the feedback form, please, on this on the DTA site. Again, probably tomorrow, the day after tomorrow, we will upload this recording of this session. And if there are any other questions, you can contact us directly, and then we are more than happy to provide or information for you. I think Simon is typing something. Yeah. Someone, would you like to add something? Because I see that you were typing.
Hi. No, it was just to say perhaps a good idea to add contact details on the course page, and then anybody viewing the content, now and into the future, will be able to reach out to you if they have any questions or if they want to collaborate with you or whatever it may be.
Okay, perfect. Thank you for that. Thanks. So we will update there. Again, we are here for you. Perfect. So fill the feedback form, and well, I wish you the Happy New Year as the end, the Happy Christmas and Happy New Year, and the successful next year. There is a question. Where is the link to the form? The link to the form is on the DTA pages. Good. That's it. Thank you. Goodbye.